Stop learning the way you were taught in school. That system was designed for a different century, a different economy, and a different definition of value. And if you are still using it today, it is quietly slowing you down while faster learners pass you without you even realizing it. Here is what most people still do not understand. In the age of AI, raw intelligence is becoming a commodity. Anyone can access the same information you can. Anyone can ask ChatGPT the same questions you ask. Anyone can watch the same tutorials, read the same books, and enroll in the same courses. Information is no longer the bottleneck, your ability to learn faster than everyone else is. The speed at which you can take something confusing and turn it into something you can execute confidently is now your only sustainable advantage. And here is the brutal truth. Most people are learning incredibly slowly without even realizing it. They binge content. They highlight everything. They take notes. They never revisit. They confuse exposure with mastery. Retention rates from traditional learning methods are shockingly low. People forget the majority of what they learn within 24 hours, and almost all of it within a week. That is not a character flaw. That is a systems flaw. But there is a different way to learn, a way that the top 1% of learners use, whether through elite training, deliberate practice, or painful trial and error. They do not learn harder. They learn strategically. They follow a rhythm that compounds. I call it the 3C protocol: compress, compile, consolidate. And today, I am going to show you exactly how this works, how to integrate AI into the process intelligently, and how to master complex skills in a fraction of the time most people assume is required. This is not theory. This is structural learning. Let's start with the real problem. Chapter 1: The 4-ounce bowl problem. Before we talk about acceleration, you need to understand why most learning fails. It comes down to what I call the 4-ounce bowl problem. Imagine your working memory as a small bowl that can only hold 4 ounces of liquid at a time. Now imagine someone trying to teach you by pouring a gallon of water into that bowl as quickly as possible. What happens? Almost all of it spills over the sides, and you are left with maybe a few drops actually remaining inside. That is exactly what happens when you binge a 10-hour course in one weekend, read an entire textbook in a week, or try to absorb everything about a topic in a single burst of motivation. It makes sense while you are watching. You feel productive while you are reading. But when someone asks you to explain what you just learned, your brain stalls. That is not laziness. That is overload. Research consistently shows that working memory can only hold a limited number of novel information chunks at once. And once that threshold is exceeded, the brain starts dropping data to preserve stability. But here is what makes it worse. Most people are not just filling the bowl with new information. They are running background processes at the same time, worrying about deadlines, checking notifications, thinking about other tasks, processing emotional stress. It is like trying to fill that 4-ounce bowl while someone is shaking the table underneath it. No system can retain information under those conditions. This is why you can watch an entire tutorial and feel like you learned something, yet fail to execute it the next day. This is why you can read a chapter and realize you cannot recall a single core idea. Your bowl was full, or the information was poured too quickly. So here is the first shift. Stop trying to learn everything. Start choosing what deserves your cognitive bandwidth. The goal is not maximum exposure. The goal is durable understanding. Without this shift, speed is impossible. Chapter 2: Compress, finding the 20%. Now we move to the first C, compress. This is where most people waste enormous amounts of time because they treat all information as equally important. But in every domain, there are foundational concepts that unlock everything else, and there are peripheral details that add nuance but do not change competence. The Pareto principle applies to learning with remarkable consistency. 20% of the concepts generate 80% of the usable understanding. Your job is to identify that 20% and go deep before you ever attempt breadth. Let's take Python programming as a concrete example. Most beginners approach it linearly. They move from chapter to chapter, giving equal weight to variables, data types, loops, functions, object-oriented programming, libraries, and frameworks. Months pass. They have covered everything, yet they cannot build anything meaningful, because coverage is not comprehension. The compress approach is radically different. You start by asking a single strategic question. What are the core concepts that, if I master them deeply, will unlock almost everything else in this domain? For Python, that might include variables and data types, control flow, functions, and fundamental data structures like lists and dictionaries. 4 or 5 concepts. If those are deeply understood, the rest becomes far easier because advanced ideas are built on those foundations. So instead of spreading effort thin across 50 topics, you concentrate effort intensely on 4. You study them, you practice them, you teach them, you apply them. You refuse to move forward until they are stable. Compression is ruthless prioritization. Top learners do not absorb more information. They filter more information. Chapter 3. Compile, making knowledge permanent. Understanding something once does not mean you have learned it. It means you recognized it in context. Real learning requires deliberate reinforcement over time. This is where compile enters the system. Your brain transfers information into long-term memory through repeated exposure spaced across increasing intervals. This is not motivational advice. This is cognitive science. Yet most people abandon material immediately after first exposure because it feels familiar. Familiarity creates the illusion of mastery. Compilation destroys that illusion. You revisit core concepts 24 hours later without looking at notes first. You attempt recall before recognition. You identify gaps. You reinforce weaknesses. You apply the concept in a real scenario within days. You review again 1 week later, then 2 weeks later, then 1 month later. Each review strengthens neural pathways rather than rebuilding them. This is how permanence forms. This is where AI becomes a powerful accelerator, not as a shortcut, as a challenger. You ask it to quiz you. You ask it to generate progressively harder scenarios. You ask it to identify blind spots in your explanations. Compilation is not glamorous. It does not feel explosive. It feels steady. But steady creates compounding. Chapter 4. Consolidate, the science of rest. Now we reach the part most high achievers sabotage: consolidation. Your brain does not encode learning during study alone. It encodes learning during rest and sleep. This is when neural connections stabilize and integrate into existing networks. Research consistently shows that sleep significantly improves retention compared to sleep deprivation, especially for complex cognitive tasks. Your brain operates in natural ultradian cycles of deep focus lasting roughly 90 minutes before performance declines. After that, deliberate rest is required for consolidation to begin. Not scrolling, not multitasking, actual cognitive downtime. 2 or 3 deep focus sessions per day are optimal for high-quality learning. More than that often reduces efficiency rather than increasing it. Sleep is non-negotiable. Skipping sleep to extend study time undermines consolidation entirely. Cramming produces fatigue. Consolidation produces competence. Rest is not the opposite of productivity. It is part of the learning cycle. Chapter 5. AI as an intelligent gym. AI can either weaken your learning or strengthen it. Most people use it as an answer machine. That removes cognitive effort. Instead, treat AI like a mental gym. Ask it to question you rather than explain everything immediately. Ask it to challenge your assumptions. Ask it to generate incorrect explanations, so you must identify the flaws. Ask it to create increasingly difficult applications of what you are learning. Growth happens at the edge of your ability. If AI removes friction entirely, growth stops. If AI increases friction strategically, growth accelerates. Use it as resistance, not as escape. Chapter 6. The Student for Life. Speed also requires humility. Most adults stop expanding their skill sets not because they lack intelligence, but because they resist looking incompetent. Learning requires temporary inefficiency, temporary confusion, temporary visible mistakes. Top learners accept this cost. They ask questions openly. They seek feedback early. They measure progress against their past self rather than against experts. Being a beginner is uncomfortable. Refusing to be one is permanent stagnation. Humility is not weakness. It is acceleration. Chapter 7. The 7-Day Learning Sprint. Now integrate everything. Day 1. Compress the core concepts deeply. Day 2. Review and reinforce through recall and correction. Day 3. Apply through deliberate practice. Day 4. Active rest and consolidation. Day 5. Build something real. Day 6. Teach what you learned. Day 7. Reflect and refine the process. Repeat. Stack cycles. Complex skills become structured. Learning speed becomes predictable. The commitment. There are 2 types of learners in the AI era: information collectors and system builders. Collectors feel busy. System builders compound. You now have a system. Compress what matters. Compile for permanence. Consolidate through rest. Use AI as resistance. Stay a student. Run sprints. Learning faster is not a talent. It is architecture. If you want to move instead of consume, subscribe. Your advantage begins when your system changes.